Hello friends, welcome back to my YouTube channel. In this class I am going to discuss about reversible cyclic devices. Reversible cyclic devices can be reversible heat engine or reversible refrigerator or reversible heat pumps. Cyclic heat engines are work producing devices, whereas the refrigerator and heat pumps are work consuming devices. In the last class we discussed about thermodynamic temperature scale, and we discussed that the temperature scale is independent of working substances. It depends upon the temperature limits within which that scale operates. So the efficiency of reversible engine is a function of temperature limits only. So how to calculate the efficiency of reversible heat engine? We'll learn in this class. So before starting, I must say one thing to all of you: please do subscribe to this channel, and of course like it and share it to your friends. Let's get started. Suppose a reversible heat engine is operating between, this is a source whose temperature is suppose TH, higher temperature, and this is sink whose temperature is suppose TL, lower temperature, and the heat engine operates in a reversible manner. Suppose this is a reversible heat engine. It extracts heat QH from source, and suppose it rejects heat QL to the sink, and it produces net work output W reversible. So what will be its efficiency? We know that efficiency of any cyclic heat engine is always equal to net work output divided by heat supplied. In this particular case, net work output is supposed, I can write W reversible. It is applicable both for irreversible and reversible heat engines. Efficiency of any cyclic heat engine or any cyclic device is net work output divided by heat supplied. In this particular case, QH is the heat supply. And according to first law of thermodynamics, sigma W cycle is equal to sigma Q cycle. So in place of W net, I can write this is nothing but QH minus QL divided by QH. So from that, I can get 1 minus QL divided by QH, where QL is the heat rejected to the sink and QH is the heat extracted from the source. So this formula is applicable for any heat engine, be it reversible or irreversible. So 1 minus heat rejected divided by heat supply. So in the thermodynamic temperature scale, we discussed that QH divided by QL, particularly for a reversible heat engine, is nothing but equal to the source temperature divided by sink temperature, when both these temperatures are expressed in Kelvin, or absolute temperatures. So that means, suppose this is your equation 1 and this is equation 2. Substituting equation 2 in this equation 1, efficiency of any reversible heat engine, efficiency of any reversible heat engine is equal to 1 minus QL by QH. This becomes 1 minus TL divided by TH. On further simplifying, this becomes TH minus TL divided by TH. This is the efficiency of any reversible heat engine, where TH and TL are expressed in terms of Kelvin only. Suppose TH is suppose 1000 Kelvin and TL is suppose 300 Kelvin. Then efficiency of this reversible heat engine will be, no matter whatever is QH and QL, the efficiency of this reversible heat engine will be 1 minus 300 divided by 1000. That is 1 minus 0.3, it becomes 0.7. And in terms of percentage, it will be is equal to 70%. So efficiency of this reversible heat engine, which operates between source temperature of 1000 Kelvin and sink temperature of 300 Kelvin, is nothing but 70%. So this is how the efficiency of a reversible heat engine is calculated, and it is a function of only source temperature and sink temperature and nothing else, and it doesn't depend upon the amount or nature of working substance undergoing the cycle, no matter whether the working substance is 5 kg or working substance is 10 kg, or whether its phase is liquid or it's a vapor phase, it's whatever may be its nature, it doesn't depend upon that. So how to calculate COP? COP of a reversible COP of a reversible refrigerator and heat pump. So हमको कैसे COP निकालना है? We know that we always calculate COP for refrigerator and heat pump. For refrigerator and heat pump, we don't calculate efficiency because COP is always greater than 1 in case of refrigerator or heat pump, and efficiency is a term which is never equal to 1 or greater than 1. It's not possible. So that's why coefficient of performance, COP stands for, COP is nothing but coefficient of performance. Coefficient of performance. So we know that a refrigerator, what it does, it maintains the temperature of a space, a refrigerated space, at a level lower than the temperature of the surrounding. Suppose this temperature of this cold space is TL, which is less than the surrounding temperature. Suppose this is your TH, it is suppose surrounding. रेफ्रिजरेटर का जो बेसिक डेफिनेशन है वो है, इट मेंटेन्स द टेम्परेचर ऑफ ए स्पेस और बॉडी एट ए लेवल लोअर देन द टेम्परेचर ऑफ द सराउंडिंग, बिकॉज if the temperature of a space or body is less than temperature of surrounding, obviously heat will flow from surrounding so heat will always leak into the space or body, no matter whatever insulation you put in. There is no perfect insulation, so whatever may be the insulation, there will be some leakages. Once the heat flows into this cold or refrigerated space, its temperature will increase. So to maintain the temperature of this space at this particular level TL, what we have to do is we have to extract the heat that has entered into this space. So we have to extract, suppose this heat entering is QL, so we have to extract QL amount of heat so that this temperature of this space will be maintained at this particular level, that is TL. Suppose the heat to be extracted from low temperature to high temperature reservoir according to Clausius statement, we need to supply some work from outside. That's what we do in refrigerator and heat pump. We have to supply in refrigerator, we supply work in compressor or motor. So suppose the work is towards the system. So this is anti-clockwise device. So this is refrigerator. So this is W and this is QH. So COP of refrigerator, we know that desired effect desired effect divided by work input. The desired effect is to remove this heat from this space so that this space is maintained or this space is refrigerated. From that the term refrigerator comes. जो रेफ्रिजरेटर डिवाइस का काम है वो है to maintain the space at a temperature lower than the temperature of surrounding. So what is the desired effect here? We have to remove heat from this space, this amount of heat, QL, it is to be removed, and work input is W in, suppose, W in. So what I can write here is QL divided by QH minus QL, because according to principle of energy balance, if you apply the energy balance principle for this system undergoing a cyclic process, always for a cycle, energy balance principle says that whatever energy enters into a system, E in minus E out is equal to 0 for a cyclic device. For a cycle, whatever energy enters into a system, if that particular system completes a cyclic process or cycle, then whatever energy that enters, summation of all the energy entering into the system during that cycle minus summation of all the energy that leave the system during that cycle equal to 0. Cyclic integral of delta E is equal to 0 because energy is a property of system. So at initial state, whatever was the energy, since the final state is identical with initial state and energy is a property, so E in minus E out will be 0. There will be no change in the energy eventually because the system comes back to its initial state. So what is the energy entering here? W in, and what is the energy coming out of this system? And plus QL is the total energy that enters, is which are the arrow sign of which are towards the system. W in plus QL minus QH is equal to 0. Energy that comes out of the system is only QH. From this what comes out is QH is equal to QL plus W in. From that, in place of W in, I can write QH minus QL. That's what I have written here. So W in is nothing but QH minus QL, or I can write QL plus W in is equal to QH, because these two are energy entering into the system and QH is the energy leaving the system. So that's why QL by QH minus QL. But what happens if the refrigerator is reversible? If the refrigerator is reversible. If the refrigerator is reversible. So for reversible case, for reversible refrigerator, according to the thermodynamic temperature scale, we have already discussed that QH by QL is equal to TH by TL. QH by QL is equal to TH by TL, where TH and TL are the absolute temperatures of source and sink. So suppose this is your equation 1. This is your COP of the refrigerator, any refrigerator. But if it is reversible, so I can also express this equation 1 like this. I will divide both numerator and denominator. This is suppose equation 2, QH by QL is equal to TH by TL if it is a reversible process. And I will simplify the equation 1 further by dividing QL both on numerator and denominator. So what will happen? COP of refrigerator will be QL divided by QL divided by QH by QL minus QL by QL. I just divided both numerator and denominator of this equation by QL. So now it becomes 1 by QH by QL minus 1. Now, suppose this is your equation 3. Substituting the value of QH by QL from equation 2 in the equation 3. So, COP of reversible refrigerator is equal to 1 upon, in place of QH by QL, I will write TH by TL, since it is a reversible refrigerator. Had not it been a reversible refrigerator, I could not have written this. So it is applicable for only reversible refrigerator, not for any refrigerator. So now this becomes, so this is, suppose this is equation 4. So this is the COP, or coefficient of performance of a reversible refrigerator, and that is TL by TH minus TL, where TL is the low temperature from which refrigerator is extracting heat, and TH is the high temperature or surrounding, in fact, to which the heat is rejected by the refrigerator. So COP of reversible refrigerator is low temperature divided by difference between high temperature and low temperature. So how to calculate the COP of heat pump? If this same device can be used as a heat pump, in heat pump what happens, the desired effect is the heat supplied to this space, higher temperature, क्योंकि हमको हीट मेंटेन करना है. In winter we use heat pump. The same device which is used as a refrigerator can also be used as a heat pump, and only just desired effect changes. And we know that we have already discussed while studying about refrigerator and heat pump that COP of heat pump is equal to COP of refrigerator plus 1. COP of heat pump is COP of refrigerator plus 1. So I can calculate COP of reversible heat pump is equal to TL upon TH minus TL plus 1. The COP of heat pump working between same two temperature limits TH and TL is equal to COP of refrigerator working between same temperature limits, that is TH and TL, plus 1. Always COP of heat pump is always greater than the COP of refrigerator by 1, no matter whether it is reversible or not. If it is reversible, means COP of reversible heat pump will also be greater than the COP of reversible refrigerator by a magnitude of 1. So this becomes TL plus TH equal to TH divided by TH minus TL. So suppose this is equation 5. You see, COP of reversible refrigerator is defined as like this: TL, lower temperature, divided by difference between two temperatures, high temperature and low temperature. Similarly, reversible heat pump के लिए COP होगा higher temperature divided by that temperature difference, TH minus TL. So how to, next is like this: more effective way of improving the efficiency of a reversible heat engine. So how can we increase the efficiency of a reversible heat engine. Suppose there is a high temperature source TH and there is a sink low temperature reservoir. Low temperature reservoir and a reversible heat engine is operating between two. Reversible heat engine. So efficiency of this reversible heat engine is nothing but 1 minus TL by TH. Suppose we want to increase the efficiency. So how can we increase the efficiency? How can we increase the efficiency? How can we increase? You see, just go through it mathematically. You see, I can increase either by decreasing TH, keeping TL constant, or by decreasing TL, keeping TH constant. Decreasing TL, keeping TH constant. Both ways, efficiency of a heat engine can be increased. Of course, TL can be decreased up to the temperature of surrounding only. Beyond that, we can't decrease the temperature, low temperature. Otherwise, we may have to resort to refrigeration. So, TL should be decreased, keeping TH constant is one way, and other way is keeping TL constant. If we increase the TH, then also efficiency can be increased. So which one is the better way? Which one is more effective? That we want to see. And this particular analysis can be done in two ways. So first is, suppose first method. This is the easier method. Suppose 1 माइनस हम TL को डिक्रीज करेंगे बाय सर्टन मैग्नीट्यूड डेल्टा T, कीपिंग TH कांस्टेंट. एंड सेकेंड जो कर रहे हैं, बाय वी आर इंक्रीजिंग एफिशिएंसी बाय इंक्रीजिंग द TH. देन व्हाट हैपेंस? TL तो कांस्टेंट रहेगा. Suppose we increase TH by same magnitude delta T. Same magnitude delta T. So which one is more? We want to find out. So if you find efficiency 1 minus efficiency 2, first case and second case, then it becomes so it becomes so if you take the LCM, TH multiplied by TH plus delta T, so minus TL TH. So this is equal to so this becomes so this is cancelled. Now it remains TH minus TL delta T plus delta T square TH plus delta T. So since we know that delta T is a positive quantity and TH minus TL is also greater than 0, so this particular term is positive. You know, delta T is greater than 0 and TH is greater than TL means TH minus TL is also positive. So numerator is positive and definitely denominator is also positive. This whole term is greater than 0. That means efficiency 1 minus efficiency 2 is greater than 0. Efficiency 1 is greater than efficiency 2. That means if we decrease efficiency 1 is nothing but we have this is efficiency 1, this is efficiency 1. We have decreased temperature of TL and keeping TH constant, and efficiency 2 is increased TH keeping T2 constant. So that means in the first case more efficiency results in. So the better way is, the better way is to decrease TL keeping TH constant, then to increase TH keeping TL constant, So there is also another method which is slope method, and if sometimes the interviewer may ask to use that method, this is a simple method that I discussed, but there is also an alternative method. So if an interviewer asks in the exam, so you are bound to solve this by using the slope method. Suppose we will increase the TH. This is the graph between efficiency and TH. So the highest level of efficiency is obviously 1. We can't go beyond 1. So efficiency, if you draw the curve between efficiency and higher temperature, source temperature, the curve will be like this. This is TL. When TH is equal to TL, efficiency is equal to 1 minus TL by TH. When TH is equal to TL, efficiency becomes 0. So here the efficiency becomes 0. And the slope decreases. The slope decreases. How can we check? How can we check that slope decreases? So efficiency is equal to, you see here, efficiency is equal to 1 minus TL by TH. So if you calculate the efficiency of reversible heat engine, we are calculating the slope of efficiency with respect to TH when TL is constant. So it comes out to be is equal to 1 का डिफ्रेंशिएशन 0 आएगा, 1 कांस्टेंट है, माइनस TL तो कांस्टेंट ट्रीट करेंगे हम, 1 बाई TH का जो डेरिवेटिव है माइनस 1 बाई TH स्क्वायर. So it becomes TL divided by TH square. So obviously when when source temperature increases, this whole term TL by TH square decreases. So that's why with increase in efficiency, increase in source temperature, the slope of this curve decreases. When TH continues to increase and approaches infinity. When TH is infinity means this term is 0. So efficiency asymptotically reaches at 1. So when you increase TH, the efficiency approaches towards 1. So that's why the curve is like this, and from moving from this to this, slope continues to decrease. So if you calculate the second case, slope of this efficiency versus TL curve, where TH is constant, is equal to इसका डेरिवेटिव 0 आएगा, तो माइनस 1 बाई TH, क्योंकि TL का डेरिवेटिव विथ रेस्पेक्ट टू TL तो 1 आएगा. सो दिस इज योर slope, minus 1 by TH. That means when TL increases, this efficiency decreases. When both these two things increases simultaneously, then the slope comes out to be positive. But here, when TL increases, this efficiency decreases. When TL decreases, efficiency increases. That's why the slope is negative, minus 1 by TH. If you draw the curve, that will be like this. And suppose this is TL, this is efficiency. And when TL is equal to TH, then what is the efficiency? 1 minus TL upon TH. So when this TL is equal to TH means this term is 1, 1 minus 1 is 0. So that's why the efficiency is 0. And when TL is, suppose 0, when TL is 0, so efficiency will be 1 minus 0 by TH, that is 1. So here the efficiency is 1. This is suppose 1. So what is the slope of this line? You can find out. Slope will be obviously minus 1. This is this coordinate of this curve is, coordinate of this point is TH 0, and coordinate of this point is 0, 1. So if you find out the slope of this straight line, that will come out minus 1 by th. y2 minus y1 by x2 minus x1. That will be 1 minus 0 divided by x2 minus x1 is 0 minus th. Obviously slope is minus 1 by th. So if you calculate the magnitude of this slope, first one, a slope of is equal to TL by TH square. Its magnitude is also, because it is positive means the magnitude is same. Magnitude. एंड सेकेंड केस में इसका जो मैग्नीट्यूड हम निकाले, ये इसका मैग्नीट्यूड ले लेंगे. इसका मैग्नीट्यूड होगा माइनस 1 बाई टी एच का मैग्नीट्यूड. ये होगा हमारा प्लस 1 बाई टी एच. इसको हम इस तरह लिख सकते हैं टी एच अपॉन टी एच स्क्वायर. सो दिस वन इज टी एच अपॉन टी एच स्क्वायर. ये वैल्यू है, फर्स्ट वैल्यू है जब टी एच को इंक्रीज करते हैं, वो है टी एल अपॉन टी एच स्क्वायर. ऑब्वियसली दिस वन यू नो दैट टी एच अपॉन टी एच स्क्वायर इज ग्रेटर देन टी एल अपॉन टी एच स्क्वायर, because TH is greater than TL. So obviously the magnitude of slope is higher in second case when TL decreases. Second case में when TL decreases, keeping TH constant, that slope of that curve is higher than the slope of this curve magnitude wise. So that means when the temperature TL, we reduce the temperature of TL keeping TH constant, the efficiency increases more effectively. So thanks for watching.